Hello everyone. Today we'll solve this example. So in the previous video we have seen how partial derivative rules we will use will simplify given partial derivative using the concept of ordinary derivative. Now here the function given is u is equal to x cube plus 3x square y plus 2 y cube x plus y raised to 4. Now we'll find first order partial derivatives, then second order partial derivatives one by one. So let us say the given equation as 1. Now differentiating 1 with respect to x partially, so you will get dabba u by dabba x is equal to, which we denote it as ux. Okay? Ux. So differentiation of u with respect to x means that is the differentiation of partial differentiation of x cube plus 3x square y plus 2y cube x plus y raised to 4 with respect to x. Okay. Now here we have to treat or we have to keep y as a constant. Okay. While differentiating with respect to x, we have to keep y as a constant. Okay. So derivative of x cube is 3x square plus derivative of 3x square y. Here 3 is constant, y is constant. So constant term we will write as it is. Now only the term which is left is x square, and the derivative of x square with respect to x is 2x plus, now differentiation is with respect to x. So here 2 is constant, y cube is also constant. So constant term we will write as it is. The derivative of this x with respect to x is again 1 plus, now here the completely term is of y raised to 4. So y raised to 4 is constant and its derivative with respect to x is 0. So 3x square plus 3 into 2 6xy plus 2y cube is the value of dabba u by dabba x or ux. Now similarly, now we will differentiate 1 with respect to y partially. It means that we have to keep x as a constant. So while differentiating throughout, we will treat x as a constant. So the notation is uy, or it is dabba u by dabba y. That is dabba by dabba y of x cube plus 3x square y plus 2y cube x plus y raised to 4. Okay. Now here we have to differentiate with respect to y. Okay. Derivative of x cube with respect to y means it is totally constant. So its derivative is 0. X cube derivative with respect to y partially is 0. And the next term in 3x square y, 3x square both are constant with respect to y. So 3x square will keep as it is. Now derivative of y with respect to y is 1. Then in the next term 2y cube x, so 2 is constant, x is constant. So that we will write as it is. Only the term left is y cube. Derivative of y cube with respect to y is 3y square plus, now derivative of y raised to 4 with respect to y is 4y cube. Okay. So that is 3x square plus 3 into 2 6x y square plus 4y cube. Okay. Now next partial derivative is uxx, that is dabba to u by dabba x square, or we can more simplified form dabba by dabba x of dabba by dabba x of u. Okay. So uxx is the notation of higher order derivative, that is second order partial differentiation. Okay. And both are with respect to x. So that is, first we have to differentiate with respect to x. again that we have to differentiate with respect to x, so that is double derivative. Okay, now dabba u by dabba x we already have, so here we will write dabba by dabba x of dabba u by dabba x, which is 3x square plus 6xy plus 2y cube. 3x square plus 6xy plus 2y cube. Now this, the value of dabba u by dabba x we have substituted. Now this we have to differentiate with respect to x again. So we need to treat y as a constant while differentiating with respect to x, okay, which is 3x square with respect to x is 6x plus in 6xy, in 6xy 6 and y both are constant, so we will write constant as it is. Now derivative of this x with respect to x is 1 plus, now the last term 2y cube is totally independent of x, so its derivative with respect to x is 0, which is 6x plus 6y. Okay. This is second order partial derivative. So first we are differentiating with respect to x, and then again we are differentiating with respect to x to get dabba to u by dabba x square, or we can denote it as u xx. Now similarly u x y, so its notation is dabba to u by dabba x first then dabba y, or we can write it as dabba u by dabba y. We have to differentiate with respect to x. Okay, so the order becomes, first we have to differentiate with respect to y and then with respect to x. So first is with respect to y, now second with respect to x. So derivative of u with respect to x already we have. Derivative of u with respect to x is 6x square plus 6xy square. Just a minute. So 3x square plus 6xy square. 3x square plus 6xy square plus third term is 4y cube, which is 4y cube. Okay. Now here we are differentiation is with respect to x, so we are keeping y as a constant. So initially we have to differentiate with respect to y, and the value, the result we have to differentiate with respect to x. Okay. Now we are going to differentiate with respect to x, keeping y constant. So derivative of 3x square is 6x plus derivative of 6x square. In this we are differentiating with respect to x, so 6 is constant, y square is constant, so 6y square, and derivative of this x with respect to x is 1 plus, now 4y cube term is independent of x, so completely this is 0. Okay. So the final solution is 6x plus 6y square. Okay. Now next partial derivative is uy y. So that is dabba to u by dabba y square, or we can write it as dabba by dabba y of dabba u by dabba y. That is dabba u by dabba y. Now we are going to differentiate with respect to y again. So dabba by dabba y of dabba u by dabba y, which is 3x square plus 6xy square plus 4y cube. So here already we have the value of this dabba u by dabba y. This we are taking from this. Now differentiating this with respect to y means we have to keep x as a constant. So the derivative becomes, x is constant and this first term is independent of y. So the derivative of this term is 0 plus, in the second term, as differentiation is with respect to y, 6x is constant. So constant value will write as it is. So derivative of y square with respect to y is 2y plus Now 4y cube derivative is 4 into 3y square. So which is 12xy plus 12y square. Dabba to u by dabba y square. The next partial derivative is u yx, which is dabba to u by dabba y dabba x, or we can write it as dabba by dabba y of dabba u by dabba x. First we have to differentiate with respect to x, then with respect to y. Okay. Now we will write the value of dabba u by dabba x already calculated. So which is dabba u by dabba x, which we have calculated earlier, is 3x square plus 6xy plus 2y square. This one, 3x square plus 6xy three x square, just we'll check again, 3x square plus 6xy plus 2y cube. If this we have to differentiate with respect to y, so here we have to treat x as a constant. Okay, so which is x as a constant, this complete term is constant, so it is 0. And here 6x constant, so constant value I will write. Now derivative of y with respect to y is 1, and here 2y cube derivative is 6y square, so which is 6x plus 6y square. Okay. So if we observe the value of uxy, the value of uxy is 6x plus 6y square, and the value of uyx is also 6x plus 6y square. So here we can say that uxy is always equal to uyx. That is, partial derivatives are commutative. So dabba to u by dabba x dabba y is equal to dabba to u by dabba y dabba x. So here derivative is first with respect to y, then with respect to x. Now here the derivative is with respect to x first, then with respect to y, but both are equivalent. So here in this, from this question, it will be clear to us that if we are differentiating with respect to x, how we are treating y and how we are writing the partial derivative, and if we are differentiating with respect to y, how we keeping x as a constant. Okay, so the basic example where it will clear the concept of partial derivative. Okay. Thank you.